Hi guys, welcome back. So what we're looking at today is 8.9. Sorry, forgot the name of it. The determinant of a matrix. So let's go ahead and jump right in. Now, for this first part, it's wanting us to solve a system of equations using row reduction. So we have the given system of equations 5x minus 3y equals 3 and 2x plus y equals 10. Zach started solving this problem by writing 5, negative 3, 3, 2, 1, 10, and then he had it go to 1, negative 5, negative 17, 2, 1, 10. Describe what Zach did to get from the matrix on the left to the matrix on the right. So what he did, how we got from having 5 to only having 1, well, we multiplied the second row by 2 and then subtracted the 2 rows. So we took row 1 minus 2 times row 2 to get the new row 1. So multiplied the second row by 2 and subtracted it from the first row to then replace the first row. So that's what he did. Now Leah started this problem by writing 5, negative 3, 3, 2, 1, 2, 1, 10, and then she got 5, negative 3, 3, so she didn't change the first row, but then 1, 1/2, 5. What did she do to that second row? Well, she took 1/2 times row 2 to get her new row 2. So she multiplied the whole second row by a half, or divided it by 2, however you want to think about it, to take and get her new solution. Now, we are not solving the whole thing using the matrices. So you do not have to do number 3. You do not have to do number 3. So hopefully you watched the video in its entirety to know that you don't have to do that. All right. Now, what we are looking at here is finding the determinant of a 2 by 2 matrix. So in order to find the determinant of the 2 by 2 matrix, we can decide if they have inverses. So the determinant is taking the these values, so doing A, D minus B, C, so multiplying that. So 8 times 1 minus 4 times negative 2. 8 times 1 is 8. 4 times negative 2 is 8, so 8 minus negative 8 equals 16. So yes, it does have a determinant. It does have an inverse. The determinant is 16. So if you get 0 for an answer for your determinant, then there is no inverse. That is the only case in which there's no inverse. Otherwise, there always is one. Now, to find the inverse, we take 1 over the determinant times this matrix here. So we just switch our A and D terms, and then we make our B and C terms the opposite sign. So we have 1/16 times, switch our A and D, so we've got 1 and 8 now, and then our B and C, switch signs. So 4 becomes negative 4, negative 2 becomes positive 2. Now we actually multiply the 1/16 here. So we end up with 1/16 and negative 1/4, and then 1/8, and then 1/2. So that is the inverse matrix of the original matrix we had. All right, number 6. Generally, matrix multiplication is not commutative. That is, if A and B are matrices, typically A times B does not equal B times A. However, multiplication of inverses or inverse matrices is commutative. Test this out by showing the pairs of inverse matrices you found in question 7 give the same result when multiplied in either order. So if we take 8 times negative 2 times 4 times 1 times 1/16, negative 1/4, 1/8, and 1/2. Remember, multiplying matrices is row by column. So row by columns, this is going to equal 8 times 1/16 plus negative 2 times negative 1/4. And then the bottom, or the next one, we'd have 8 times 1/8 plus, sorry, I just lost where I was, -2 times 1/2. All right, then we'd have, so row by column. Now we have 4 times 1/16 plus 1 times -1/4. And then take the 4 times 1/8 plus 1 times 1/2. Now we simplify this. 8 times 1/16 is going to give us 1/2 plus 2 times -2 times -1/4 will also give us 1/2. And then, which means that's 1. 4 times 1/16 is 1/4 plus -1/4, which is 0. Then 8 times 1/8 is 1 plus -1, because -2 times 1/2, which is going to give us 0. And then 4 times 1/8, which is 1/2 plus 1/2, which gives us 1. So it does give us the identity matrix. And I will tell you, it's going to give us the same thing if we do it in the reverse order. I'm not going to show that. And you do not have to do it on any of the others if they end up being, if it ends up being possible to take the inverse, okay? So that's all using the determinant to take and find inverses. So determinant is your key word for this lesson, determinant. Section, we want to determine whether the following pairs are parallel, perpendicular, or neither. So in order to take and do this, looking at this first one, we have to convert these into slope-intercept form to make it a little easier. So we have 2y equals -3x plus 7 divided all by 2. So this one is y equals -3/2 x plus 7/2. Now our second one, 6x plus 4y equals 9. Subtract our 6x, so we end up with 4y equals -6x plus 9. We divide by 4. So end of y equals, now -6/4 will reduce down to -3/2x, and then plus 9/4. Now, if we take and look at this, both of our equations have the exact same slope. They both have a -3/2 slope, which means they are parallel. Remember, if they have opposite reciprocal slopes, they are perpendicular. If they aren't either the same slope or opposite reciprocals, then it's neither, okay? So that's what you're looking at for 8 and 9. And then for 10, you're writing the equation of a line that's that's parallel to the given line and goes through the specific y-intercept. So make sure you use this for your y-intercept, not just a random y-intercept, okay? All right, if you guys have any questions, feel free to ask. Have a